Welcome to this tutorial on relations, mapping, and functions. Today, we'll explore these foundational concepts in mathematics and see how they are used to analyze relationships between sets. A relation in mathematics is a way to associate elements of two sets. The first set is called the domain, while the other set is called the codomain. For example, we can decide to create a rule that relates every even number to 0 and every odd number to 1. The relation can be represented with an arrow diagram, where 5 relates to 1, 11 relates to 1, 6 relates to 0, 10 relates to 0, and 1 relates to 1. Meanwhile, 1.5 is not related to any element in the codomain. Also, 2 is not related to any element in the domain. And that's because a relation doesn't have to link every element in one set to every element in the other. It just depends on the rule defining the relation. Now, let's talk about mapping. A mapping is a special type of relation in which every element in the domain maps to something in the codomain. Also, two different elements in the codomain cannot be mapped to the same element in the domain. For example, we can have a mapping that maps some cities in the world to the country they're located. London maps to England, Madrid maps to Spain, Munich maps to Germany, Manchester maps to England, and Milan maps to Italy. In other words, we can also say, England is an image of London and Manchester, Spain is an image of Madrid, Germany is an image of Munich, and Italy is an image of Milan. The set of all the images is called the range of the mapping. As we can see, every city in the domain maps to a country in the codomain, and no two country is an image of one city, which is logically reasonable because one particular city can't be found in two countries. Though Nigeria is not an image of any city in the domain, and that's because no city in the domain is located in Nigeria and is acceptable for a mapping. The next concept we'll be talking about is functions. A function is a mapping whose codomain is a subset of the set of real numbers. Though some people use mappings and functions interchangeably, but I think it's better to use mapping as the general term, and then use the term function when dealing with numbers. An example of a function is a rule f, which takes any real number as an input and produces the square of the number as an output. Mathematically, the function can be denoted as f of x equals x squared. It can also be denoted as a function ef that maps x to x squared. If we represent the function with an arrow diagram, 0 maps to 0, -1 and 1 maps to 1, -2 and 2 maps to 4, and so on. In summary, in a relation, an element of the domain can be related to two different elements in the codomain. Also, an element of the codomain can be the image of two or more different elements in the domain. Also, it's possible for an element in the domain not to have any image in the codomain. But for mappings and functions, two different elements in the codomain cannot be an image of the same element in the domain. Also, every element in the domain has an image in the codomain, and then it is not compulsory for every element in the codomain to be the image of an element in the domain. I'll leave you guys with an exercise to point out which of these arrow diagrams represent a mapping. Make sure to subscribe to this channel so you'll be notified whenever we drop a new video.